Dear Professor, I would like to submit my homework workshop number 5 about control system and control stepper motor by Arduino. For the hardware, I need the Arduino 1 and the L298N for the driver of motor, and the switch just one. We can use the red, orange, blue, or the green. There are four. We just need one. And the stepper motor, like this, it's 28 BUIG48. The the power is 5 voltage. Okay. Next, I will introduce the about the step motor. The stable motors converts electricity into rotation. Not only does a stable motor convert electrical power into rotation, but it can be very accurately controlled in terms of how far it will rotate and how fast. Stepper motors are so named because each pulse of electricity turns to the motor one step, and a step motor is a brushless electrical mechanical device that converts a series of electric pulse applied to its excitation values into precisely defined step-by-step mechanical shaft rotations. The motor's shaft rotates through a fixed angle. The fixed angle is named step angle for the step motor uh, rotate. For each discrete pulse with this rotation being either linear or angular, a single pulse input results in a one-step movement. Like this, this is the construction of a stable motor. Like all electric motors, it has a stator and a rotor. The rotor is the movable part which has no windings, brushes, and a commutator. Usually, the rotors are either variable reductance or permanent magnetic cam. The stator is often constructed with multiple and multi-phase windings, usually of three or four phase windings would for a required number of holes decided by desired angle displacement per input pulse. Unlike another motor, it it operates on a programmed discrete control pulses that are applied to the stator windings via an electronical driver. The rotation occurs due to the magnetic inter interaction between poles of 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 sequentially energized stator winding and the poles of the rotor. Next, this picture, the 28BYG48 stable motors are one of the most commonly used stable motors. In the picture, you can find this or similar motors in your DVD drivers, machine camera, and any more similar devices. The motor have 4 pins. There have 4 pins. There just have 4 cores, unipolar arrangement, and each core is rated for 5 voltage, vo- for 5 voltage, and it's relatively easy to control with any basic microcontroller. The motor running only on 5 voltage and hence can't provide high torque. For high torque application, you should consider the other motors. The stable motors used for CNC machines, precise control machines, safety cameras, and so on. Look, there have 4 pins cores. The one is right here. Its VCC connects the 5 voltage, and the other 4 cores is one is blue, like this blue. The other ends like blue, orange, pink, and yellow are taken out as wires. The red wire is also provided with a constant 5 voltage supply, and this 5 voltage will be across the coil only if the other end of the coil is grounded. A stable motor can be made to rotate only if the coils are grounded in a logic sequence. This logical sequence can be programmed using a microcontroller by designing a digital circuit. In here, the left picture is the physical connection. The right picture here is 2 pictures is the code in Arduino. Next, I will introduce the code, the program in the Arduino. In Arduino, number 1, we'll create the include the stepper 28BYG48 stable motor and stable the pin 1, pin 3, pin 2, pin 4 and 4 pins. The pin definitions like this. 1 pin 1 connect the 8 pins 8 pin in Arduino. The pin 2 connect the 9 in the Arduino. The pin 3 connect the 10. The pin 4 connect the 11 of the Arduino. Okay, they define the SW. It's the switch. Connect the pin about on the Arduino 30. The switch input is 30, and the step there is 3 nanoseconds. The step delay is small. The speed of a stepper motor is high. If we can see it about 10, the speed is now. In the word step, I was setting the pin model. Pin 1, pin 2, pin 3, pin 4 is output. The SW, the switch pin, is input. Another enter the motor state. The pin 1, pin 2, pin 3, pin 4 is null. In the word loop, because because the stepper, the I/O port outputs of the stepper motor a high level when the key is not acute. The key, the switch, not acute, the level is high. And but if the key is pressed, the switch closed, the level is low. So I, I define a set if the digital read from the switch is null. When the symbol is null, it means the switch is closed. The, the line is connected. So I said the single step 1, 2, 3, 4 is CW. It means rotate clockwise. The motor round rotate clockwise. And if the digital read from the switch is high, it means the switch is open. So let's set the single step 0, 0, 0, 0. This means this. In the state, the motor state, the motor is stop, no run. And here, single step control function. I int the pin 2, 1, 2, 3, 4 pin and define the sequence at 1, 0, 0, 1, 0, 1, 0, 0. Next, this. And the iterational step sequence at the I equal 0 and not more than 4. The 12 pin 1 step A 0 like that. 1 like that. 2 like that. 3 like that. The step and end the delay for these two here. Delay a step delay. The next step delay like this equals set is 3. Okay. Let me share. Now the motor stop. The step model is not run. Stop. I set the 13 of the Arduino. Connect the Q1. Q1 is right. Okay, I will press. When I press, we can see here the motor is running clockwise. Okay, when I not press, okay, it's a high level. The motor is stopped. Again, the king is low level, so the motor is running. Okay, thank you. This is my whole introduction about the homework 1 shot number 5 about control stable motor by Arduino. Thank you, sir.